Hey, welcome back. So we're going to take a look at 3.2b. We're still in translation. Just kind of broke the notes up a little bit there. And here we're going to take a look at how the ribosome actually starts to put together those amino acids and how that code is translated from RNA to amino acid. All right, so we're going to kind of zoom in a little bit more right here on this particular strand. So I'm going to call this my mRNA strand here again. Hopefully we start to recognize that in just a second. And like I said, just for this particular drawing, I'm making it very accurate, very small. You can see the actual individual nucleotides here. And we make kind of a dotted line because it would be a lot longer than this. That one's really tough to read. That should be a G there. Okay, so what we have happening is here's our mRNA strand. Again, it's our mature mRNA. It's been edited. It's probably left the nucleus, and it's going to fly out into the cell, and it's going to find a ribosome, or a ribosome is going to find it. And the small subunit is going to attach first, and then you guys know the base pairing rules, so you could tell me what pairs up with AUG. And yes, it's very specific. It does have to be AUG. We'll talk more about that in just a second here. There's our kind of our tRNA here. And there's the anticodon. And then up on the amino acid, I'm going to put MET for MET, for methionine. That's a specific amino acid. There's 20 different amino acids, and that just happens to be one of them. And it actually happens to be the first amino acid every time. So what happens? The small ribosomal subunit kind of grabs hold of the mRNA. At the same time, the tRNA start or initiation sequence comes over, and that's always attached to a MET mat. We'll talk more about that in just a second. And then finally, once those two connect, they connect first, then the large subunit comes over. So there's those APE sites, and he's going to fly over, and he's going to kind of attach and build himself around all the rest of this. All right, so what we have happening here. Oops, not the initiation, the initiator. Initiator. Initiator tRNA. All right, there we go. Sorry about that. So the small subunit, it's this guy here, binds the mRNA, as does the initiator tRNA. In eukaryotes, and that's our cells, it's always the codon AUG. So if you guys remember from part A, we looked at three-letter sequences being words that we call codons. And for our cells, the start codon, the initiator tRNA, is always AUG. And we'll learn how to read this, get some practice in here. This is called the codon wheel. Now, keep in mind, guys, it's called the codon wheel, not the anticodon wheel. So we are reading, remember the codon is on the mRNA, not the tRNA. We don't really care about the tRNA. That's just there to match up. We care about the codon on the mRNA. So if you haven't got one of these, please ask for it. Should be plenty available for you guys, a codon wheel. And how we read it, we'll go ahead and start. Here's the codon, A, U, G. So whatever the first letter in the codon is, we start in the middle. It's either going to be A, G, U, or C. We're starting with A, so we're going to start here with A. Then we go to the second codon, and that's U. So since we're starting with A, we're going to stay in this quadrant here, and we're going to come up to U. So from A to U. Again, I'm not going to go to this U. This U is attached to C. I'm not going to go to this U. This U is attached to U, and I'm not going to go to this U. It's attached to a G. I'm staying to the U that's attached to A because my first letter was A, my second letter is U, and my third letter then is G. So attached to this U is my G, A, U, G. There's my first codon, and it's your guys' first. Oops, there we go. It's your guys' first time reading a protein wheel or a codon wheel. AUG, and that is methionine. And that's our start codon. So AUG is always the start codon. If you don't read AUG, you don't start. So since we always start with AUG, our first amino acid is always methionine. So you guys are seeing that here. Here's our methionine. I usually just use a 3-letter abbreviation, the first 3 letters. It's not technically correct, but we're going to roll with it for this class. So MET for methionine. So yeah, every protein we have starts with MET unless it falls off later, but for right now, let's kind of talk with that. So there we go. There's our first amino acid in a growing protein. Finally then, or next then, the large subunit joins. So we see him kind of flying in it over here. And once he joins, we're ready to roll. So we come down here into the cycle now. And now I'm not going to draw with quite as much detail. I'm really testing my artistic abilities today. So here's our A, P, and E sites. And here is, I'm just going to draw the letters now. Here's our start codon. And so here is the anticodon. And here is methionine, the amino acid, attached on top there. So there's our tRNA kind of loop here. He's got that anticodon that binds. That's how we know which one to bring over. And now we can read our next codon, which I have here as UAC, it looks like. UAC. So coming over, the ribosome reads that next 3 letters. I'm just going to call over the next tRNA. How does it know what the next tRNA is? Well, because of these 3 letters. A is going to pair with U is going to pair with A, and G is going to pair with C. So our next anticodon, he's flying over now. You can see him. He's going to bond. It's going to be AUG. Let's figure out what amino acid we should put on the top of this one. Again, read the codon, not the anticodon. This is good. This is not good. So we want to read the UAC codon. So here's U, first letter, start in the middle. Then A, then C. So UAC, there we go. First 3 letters, TYR. We're going to add the amino acid tyrosine, TYR, because we're UAC. Always working out from that codon wheel, UAC. Now I'm going to draw a different shape than a circle. I use circle for met. I'm going to use a square, just for the sake of using a square, for tyrosine. The reason why I do that is we have 20 different amino acids. And each of these amino acids are a little different, kind of how a circle is different from a square. And that's really important for once we get our protein built, what shape does it have? How does it function? What does it look like? Et cetera, et cetera. All of that is really important. So I've changed my shape. I don't have a circle this time. I have a square. There's a ribosome, our small subunit on bottom. Oops, I lost you there. Our small subunit on bottom, our large subunit on top. We've now got two tRNA in there. And what's going to happen next is our ribosome is going to link the two of them. This is our peptide bond that we discussed just a second ago. Peptide bond between amino acids, and that gets formed here in the second step. So the first step up here, the ribosome attracts the next tRNA, calling them over. The second step, now that he's in there, is going to go ahead and form this peptide bond. So our peptide bond gets formed. All right, and our next step, the whole ribosome is going to kind of slide over. It's going to start reading. I'll go ahead and add another codon here. We'll just call this one AAA. So we're going to continue to read down this mRNA, kind of like a TikTok. Nope, not that. Kind of like a ticker tape line. He's going to pull that and pull himself across it. He's going to read 3 letters at a time, codon by codon. He's going to read. And when he does that, he's going to push this first tRNA. So you have the first tRNA, he gets pushed over to the ejection site right here. So we'll see that here. So again, my AUG is now in the E site. He's ready to be ejected. And you can already see, hey, we're going to be looking for a new amino acid at this point. Now notice I'm not drawing the amino acid methionine on top of this tRNA. He's now empty. He's not holding on to an amino acid anymore. Where is it, you might ask? Well, it's a very good question. So here's our TYR, tyrosine, and connected to that through a peptide bond is our original methionine. There he is. So he's come off of this start codon. This tRNA no longer is attached to him. He kind of lost him. He kind of gave him up. He's now bonded this one. This one's kind of got 2 of them there. That has got connected through a peptide bond. And what we're seeing here, this is a growing what we call polypeptide chain. AKA, so it's also known as a protein. So we are growing a protein here. You can see we're 2 amino acids deep, and the next step here is we're just going to go back in the cycle. So you can imagine moving back up to this slot here. Instead of calling over an AUG, we're going to call over a UUU. That'd be our next tRNA that's going to come in. And when that happens, the empty UAC tRNA, so there's an anticodon, he kind of flies off. So this spot's now empty. Instead of having the methionine here, we'd have the tyrosine, and the methionine would be up here, and we're going to call over a new amino acid, which make it a different shape. Go through the process again. This time we'd eject this tRNA, and the new one we're calling in is going to take the middle spot, and this now would be 3 amino acid chain. It's going to be connected to him. That cycle is going to continue several times until eventually, we have it all fall apart here. Follow what I'm doing. So the ribosome falls apart, the big unit comes off, the small unit comes off, the mRNA comes off. Let's go ahead and draw our polypeptide. He's coming off. He's down here. And we started MET. Then we went TYR. Whoops. And he was a square. And then let's see, what would the next, one more practice reading the codon wheel. What would codon AAA give us? A. Lysine, so LYS. I'll go ahead and make this one as a triangle. And there's another peptide bond between them. And then there might be like a rectangle after that. Not sure what we're going to make after that. And then maybe, like a double circle, like a figure 8 maybe. And then he's going to be connected to, we just have something going off the page here, some artistic effects. And so here's our growing polypeptide, or it's now actually a completed polypeptide. So the subunits fell apart. The mRNA kind of goes off on its own way. Actually, he'll probably go find another ribosome that's going to go ahead and make this protein again. When we decide it's time to make proteins, we make proteins. We're going to make probably hundreds, not even thousands of them all at the same time. But there's our growing polypeptide. It's now mostly a protein. We might have to go add some more things to it, but mostly it's a protein now, ready to do its job, ready to go out into the world and do its thing. So one quick note of all that. All right, so here's the finish. Eventually, you're going to get to what's called the stop codon. So you're reading, you're doing this process, you go through this cycle several times, get a longer and longer and longer chain. But eventually, you're going to read the stop codon, and you'll notice there's actually 3 stop codons. UAA, UAG, and UGA. Those all result in stop. Stop is not an amino acid. There's no amino acid called stop. It means translation is done, stop, and everything kind of falls apart, and your protein is done, and it can go do whatever job it needs to do. This is our protein. This is our protein right here. All right. Well, if you have any questions on this, I should be back. Should be back the next time we have class. So feel free to ask. But otherwise, got an assignment for you. It's going to be another. It's going to go into another lab grade. So make sure you guys are doing it. Not a homework, a lab. You guys should bring that back to me on Wednesday. Hopefully, have time to work on it here in class and finish up what you don't finish at home. But otherwise, have a great day, and I'll see you guys Wednesday.